Good morning, everyone, or afternoon, evening, wherever you're joining us. It's morning here in the United Kingdom. We're very excited to be giving you this presentation today. My name is Jareth Reeves, and I'm a Managing Director at Kaleido, and I'm joined by my colleagues, Jake Williams and Rob Butler. We're a consultancy specialising in the transformation of capital project delivery through the use of advanced knowledge management services to ultimately empower decisions and enhance project outcomes with decision intelligence. Today, we're going to explore something that's really changing how we handle risk in major capital projects through the application of Neo4j graph databases for complex risk portfolios. Major capital projects are typically multi-year infrastructure public investments such as nuclear power plants, railway systems, or highways. What we'll be demonstrating today is some practical solutions we've implemented to help capital project teams tackle diverse and complex risk portfolios worth billions of pounds, showing how graph technology can transform overwhelming data into actionable insights. In this session, we'll cover the importance of visualization, demonstrating Neo4j's capabilities, along with explaining our data journey, and overview of our use cases with some examples of applications of the graph in our domain. By the end, we aimed that project practitioners could walk away knowing what immediate value they could get from Neo4j and an introduction and understanding of what its capabilities are. For data scientists, we hope to present a fascinating challenge. How do you model and query or even validate complex risk networks viewed this way for the first time, where a single change can cascade through thousands of interconnected nodes, each representing critical project elements? Following this, we will also be providing an overview of how we are optimizing our enterprise AI solutions with Graph RAG, this year's innovation in the graph space, as vastly improving the retrieval, understanding, and querying of project data, where we'll be looking at risk specifically. Before we dive into this, let me decompose some of the challenges that we're facing as a project profession, with risk in particular, and the irony of these causes and effects that threaten deliverability of desired outcomes and the ability to remain on budget and on schedule. One of the core challenges in our field is fragmented data within project organizations. Data that is siloed across processes, platforms, functions, and teams. A common scenario is a risk manager embedded in a cross-functional team managing risk data in a standalone database. This risk data is captured, assessed, and managed in isolation from other project data within its platform, which also has additional white space between different project folders, which could be managed by different individuals with common issues with the variability in data quality, consistency, and validity, just to list a few. The disconnect makes it feel difficult to explore project risk data holistically or understand potential interdependencies across the portfolio, either relationships between risks and other risks, but also other project characteristics such as schedule and cost. Yet these crucial links are often buried in separate systems, hidden from the broader view needed for effective decision-making, mitigation, planning, assessment of true risk exposure, and more. Here's where knowledge graphs offer a powerful solution by mapping relationships between risk data, schedule, costs, and more. Knowledge graphs can bring siloed data together, creating a connected view of your project. With this, we can leverage advanced analytics to assess risks in context, unearth interdependencies, and ultimately drive smarter, more proactive mitigation plans and decisions. The second challenge is growing complexity in a hyper-connected world and the capability gaps in adoption of exponential technologies. The world we live in is rapidly evolving, yet the project profession is often stagnant, held by an industrial age mindset. The need to do more with less has never been more pressing, with more and more public investment decisions needed. Closing these capability gaps is crucial to leveraging advanced tools like AI, machine learning, and knowledge graphs effectively. Without these capabilities, we risk falling behind, unable to meet the demands of today's projects and fully harness what these technologies can provide. These two challenges, fragmented data and outdated approaches, highlight the critical need for an integrated approach to project management. By addressing these, we can transition from reactive, isolated processes to proactive, interconnected strategies that support better decision-making and resilience. Now, I'm going to hand over to Jake, who will be presenting some demonstrations of what dynamically visualizing and querying risk data in Neo4j looks like, with an overview of the data journey, use cases, and future roadmap.
Thank you, Jareth. Hello, everyone. Good morning from the UK. So my name is Jake Williams. I'm a principal consultant at Kaleido, and I'll be demonstrating some of the features of our risk register graph. So Jareth mentioned some of the siloed data, and that is sort of particularly true in a couple of the key databases that we use in project management. So that's the risk database and the schedule database. These databases provide the foundation for sort of understanding some of the potential challenges that could affect the projects and the timeline of the activities that we manage. So just a quick introduction to those two. So the risk database captures all of the identified risks associated with the project. It includes detailed information about the nature of the risks, such as the causes, impacts, probability of the risk occurring, and mitigation strategies. And then there's the schedule database. The schedule database, or P6 database, as it's sometimes referred to in the industry. It's a market-leading tool, contains all of the key activities and milestones within the project. It provides a comprehensive overview of the project timeline, including start and end dates, task dependencies, resource allocations, and critical path activities. And this database allows us to monitor the project's progress. So together, these two databases offer an integrated view of project risks and schedules, and linking them together in a graph can overcome some of the issues that have developed in the silos over the years. And just to note, the data that we've used in this graph is a synthetic data set of a large public sector organization and their risk and schedule data. So we'll start by opening up the graph in the Explore pane in our Neo4j instance. Now I've opened up all the risk nodes from the various risk registers. We can inspect one of these particular nodes representing a ground conditions risk, and we can see all the properties contained within each risk. And this includes things like the quantitative assessment, risk exposure dates, the status of the risk. And if we take this one particular risk, we can also see a node representing the cause of the risk. We can see the category that the risk is assigned to, ground and environmental in this case. And we can see which project that risk could impact, including all the details about that project. And whilst we're here, we can also see which parent program this project is a part of. And we can see that the risk is also connected to a P6 or schedule activity node via a could impact relationship, which includes all the details you'd expect to see in P6 as properties of the node. And this includes things, as I said, like start, finish date, resources required. And then we might also be interested to see all of the other risks that are linked to the same activity, to see what the risks are to that particular part of that project. We can also then see mitigation plans that have been applied to the risk, as well as things like the risk owner, and then later on in the video, we can then see what happens when we expand the mitigation plan to see the specific response actions which form part of that plan. So I'm just going to leave that on there. And move on to our visualization of the project hierarchies in Neo4j. So in the graph displayed, each blue node represents a unique project. The size of the node is directly proportional to the project's value, allowing us to quickly identify high value projects at a glance. So in terms of the hierarchy and the structure, the nodes are arranged in that hierarchical structure with level 1 portfolios positioned at the top of the graph, moving down to programs at level 2 and projects at level 3, with then sort of sub-projects of those projects below, culminating with level 7 at the bottom. So I'll just play that video again. And this vertical arrangement reflects the tree-like organization of the projects, showcasing how larger projects might encompass several sub-projects. And then on the right-hand side, you can see the properties that we're able to see by selecting a specific node, like the one labeled depot and infrastructure. And we can delve into its detailed properties and see a bit more about that particular project. We also use Neo4j to store data, as I said, derived from multiple different sources. So this is obviously the risk database and the schedule database. And by doing that, we enabled certain things to happen. So in this case, we could utilize Cypher queries to check the data, to cross-check the validity of the data in the risk database. So we're using the schedule database to make sure our risk database contains valid data. So here we're connecting previously often disconnected data between the WBS and our risk breakdown structure. So in this example, we use the start and finish dates from our schedule database to update the risk exposure start and end date for the risk it's connected to, because that's often a problem in major project risk management. And this means that the risk exposure dates can be updated with realistic dates. And we'll show how we did that with the specific Cypher queries later on. I'm just going to introduce a concept here for those unfamiliar with risk management, because it will be useful later on. So it's the concept of EMV, expected monetary value, and this allows the user to sort of calculate the weighted average value of a risk event, which includes uncertain outcomes. And it's useful for high-level analysis, as it doesn't require any specific software as such. Here we're demonstrating a table generated from a Neo4j query that provides insights into the number of connections each individual system in our system has. So before I mentioned a person node, and a person can manage mitigations, they can manage risks, they can manage activities, and this query just shows how much they have on their plate and how much they're responsible for managing. And we can see if somebody is overburdened, and we can also see at the sort of total expected monetary value they are responsible for overseeing. We're also able to dynamically visualize the risk nodes in our database. So here we can see the visualization of the changes in expected monetary value across all the risks in our system. Reporting is often an issue in major projects. So this brings the reporting up a level. The color and size of each node is providing insights into the change in EMV. So the green nodes represent the risks where EMV has decreased since the last assessment or positive, and the red nodes, on the other hand, indicate where the risks have increased in value, which is obviously not desirable. And then the size of each node is directly proportional to the current EMV value, so you get an idea of the magnitude of the risk that it represents. And then this is the view of the sort of the evolution of that project hierarchy we presented a couple of slides ago, but this time incorporating the risks for each project connected to each project in that hierarchical view. So the original nodes are still present and arranged in that hierarchical view. But as I said, this time we've connected the risks in there so you can see all the risks to each project. And then that enables us to run queries like the one you can see here, where we can filter for EMV over a certain value. So here we've got the change in EMV is greater than, it would be 1 million in a month, and we can see which risks are sort of evolving at a certain rate. So we've been through the sort of output and some of the insights you can generate from our risk graph. Now I'll take you through the how and how we arrived at this point, showing the methods that we use to transform the risk database into some of these insights in Neo4j. So in terms of the raw data, what you're seeing is a snapshot of that from our risk database. The data is presented in a tabular format with each row representing an individual risk entry. And the reason we're doing this is to overcome the limitations of tabular data. So while it's useful for storing and retrieving structured data, it's got its limitations when it comes to visualizing complex relationships and performing advanced queries, such as if you wanted to slice across the data from both a portfolio program and project perspective, as well as different systems like civils, M&E, and commissioning. And then this is our transform data and import stage. So this step was critical in terms of converting the flat tabular data into the structure in Neo4j. And just to summarize, we take the data out of the databases, do some manipulations, sometimes in Power Query, and then we use Python to create and load the nodes in the relationships into Neo4j. And then here we're illustrating the result of that. So this is the data model or risk ontology that was created using the outputs from the Python script. So this schema is the backbone of our Neo4j database, and it's obviously scalable and will allow us to add elements to this graph as we want it to evolve. So here we've got just a key reminder of another couple of concepts that will be useful. So again, a reminder of the schedule database, and then a reminder of the risk exposure dates that we mentioned earlier, which are the sort of specific time frame during which a project is exposed to a threat. And this is how we went through the process of combining the data from the schedule database with the risk database to update those risk exposure dates. So we used various sort of Cipher queries to transform the data. And I'll just move this along briefly. Give me 1 second. There we go. If we go from about there. So you can see here we're aligning the activity start and end dates with the risk exposure dates, and making sure that they're all valid and up to date, and they make sense based on the latest schedule data that we have. So you can see here that they're all starting to align, and our risk data set is going to be much more valid than it was previously. And then we do a final sort of check just to make sure that everything is as we expected it to be. So we've got that alignment there between the risk exposure date and activity start and end date. And then there we do that check just to make sure that all those dates are aligned and we've got that validity. And then finally, in terms of the data journey, we've got the visualization. So these sort of screenshots demonstrate how we utilize the rule-based styling feature in Neo4j to enhance the analysis of the risks by demonstrating the change in EMV and the current EMV using the color and the size of those nodes. So just sort of finally on this piece, we just want to highlight some of the use cases for this graph that we've been through. So the first one is to visualize the hierarchy. So the use case allows for better portfolio management, strategic planning, and performance monitoring by offering a structured view of projects from top to bottom. Second one is resource allocation, resource management, identifying overburdened individuals and optimizing resource allocation. Third one is the holistic and cross-systems view that I mentioned. So providing a comprehensive understanding of risk distribution across projects to support cross-functional risk management across different systems and teams, bridging those silos. Fourth one is monthly reporting, providing a different view of the data as it changes month by month, or even more frequently week by week. Fifth one is the one that we just went through, which is aligning those exposure dates. So exposure date alignment between the data in the schedule, which is more likely to be up to date, and the risk exposure dates to support more accurate cost forecasting. And then finally, senior management decision making. And now just a sort of a look into the future in terms of where we want to take this. So this slide represents our future vision for expanding the graph model to include even more project data, such as a cost breakdown structure, requirements, suppliers, contracts, and more. So at the moment, our graph focuses mostly on risks and those P6 activities, as we've mentioned. But this future vision that we have, includes much more data and has the potential to provide greater insights. So, for example, you might be able to understand how a change in requirements might affect downstream project activities, and then you might be able to do something about that ahead of time. And then we're also looking to explore how Neo4j graph data science can be used, focusing on things like between-us centrality to identify bottlenecks within schedules. And so that's where we'd like to take it next. So that's it from me. I'm going to hand over to my colleague now to take us through how we can use GraphRag on this risk graph that we've developed. Over to you, Rob.
Hello, everybody. My name is Rob Butler. I'm also a project consultant here over at Kaleido. So I'm just going to talk briefly about some of the implementations of the risk database that Jake's been taking you through with our GraphRag implementation. So I'll just move on. So I'm sure you're all probably aware of GraphRag and what its capabilities are. But with this particular use case, we saw this as being quite useful. To give a bit of context, we've got, in many organisations, you've got risk registers scattered all over in multiple locations, hidden in various recesses of file systems, which makes them inaccessible or hard to find for projects teams. And even when they are found, it does require a certain amount of expertise to interpret them. So the idea behind the GraphRag implementation was to free up this data so that it's accessible to a number of different stakeholders. So what this will enable us to do is to automatically convert the queries that a project manager or a risk manager might enter into the chatbot and translate it into complex Cypher queries. It will be able to interpret the data, the graph, and convert the Cypher into the actual relationship types, even if the user is to enter a query that doesn't necessarily reference the exact properties of the node or the relationships. So an example of that could be if they're asking for the most critical risks on a project, it will be able to interpret that as the severity of the risk or the impact and apply it above a certain threshold, all behind the scenes. So this opens up the graph database for the different stakeholders. So I'm just going to take you through into the design pattern for this. So the way that we've constructed this is to build it into a agentic model, whereby we've got a number of different specialized agents within a hierarchical teams format. We can extract the data from the graph database, and then if the query requires it, we're able to combine that retrieved data with best practice from across the industry to suggest potential mitigation actions or help construct an initial risk management plan, for example. We might also be able to look at other similar projects online through use of the internet researcher to look at if there's any projects who may have faced similar issues in the recent past that we could draw some lessons learned from. We also have other database repositories like lessons learned across the industry, across the organisation, where we're able to draw upon experience that over the past however many years we can use to inform better responses to those risks that we've identified. So here's a little demo of this in action. For the purposes of this, it's a relatively simple query, but we're able to see the ease of which somebody like a risk manager or a project manager, somebody who's non-technical by their nature, could just enter in a simple query such as this, which is to find all of the risks associated with a particular project. And for each of those risks, give you some key information about the causes, effects, and the total estimated monetary value for each risk. So whilst this has been on the demonstration, has gone through from a project manager, it could equally be from different stakeholders like a senior program manager who might want to look at not just a specific project, but looking at the cumulative total of risks across a number of different projects. And we're able to, through the use of this chatbot and the architecture behind it and the way that the graph's been set up through the ontology, to be able to aggregate that and look at the data in various different formats. And what I'm doing here is just demonstrating the agentic model here, where we can ask a follow-up question to the retrieved data that we've just pulled out, to look into our document repository, which we've got stored in vector databases, to, in turn, of each risk that we've pulled out, find if there's any kind of best practice that we could apply to that to help us mitigate that risk for the business. As you can see below, we've pulled out for the top 3 risks on Project Zeus some suggested mitigations based off information that the chatbot has found online, as well as through our vector database. So that gives a good demonstration, a little flavour for what's possible. So that is all for our GraphRag. So that takes us to the end of the presentation. I know it's not left us any time for questions and answers, but if anybody does want to follow up with us and ask any further questions, or you can see an application for this in your own business potentially, please reach out. We'd be happy to talk about the solution in more detail and how we came to produce what we did. There's plenty more that we haven't been able to show you in the half an hour, so yeah, we very much welcome anybody to reach out to us. So I think we'll wrap it up there. There's a QR code. If you'd like to give it a scan, you can find us on LinkedIn and contact us from there.